Hello. Today we're going to finish talking about rate of change and slope. We started yesterday with examples 1 and 2. We are going to continue on to 3 through 5. So let's get started with example 3. In example 3, they're going to give you a line, and your job is to find the slope. Usually the easiest way to do that is find two good points. Usually the two closest good points are how you want to handle this. So if we looked at this one, that looks like a good point, and up to over one, that looks like a good point, and I can see that they all look like they're on that kind of line. If I just check the horizontal change, this horizontal change is 2, and this vertical change is 2, and the horizontal change looks like 1. Remember, slope is rise over run, so for my red line, I have 2 over 1, which is just 2. So the slope of the red line is 2. Let's take a look at another one. And it's this green line. So I'm going to look at the green line, and I see a pretty good point right here. And looks like another good point right here. And that to me looks like a rise, 1, 2 of 3. And a run of 1, 2 of 2. Okay. And so again, rise over run for the green line is 3 over 2. I can't reduce that. I'm just going to leave it as 3 over 2. And I got one more I want to look at, and that's this blue line. Looks like I got a couple good points here and here. All right, that horizontal change is negative 1, right? I'm going down 1, and then forward positive 2. That's the horizontal. So for the blue line, that gives me a change of negative 1 over 2, which just simplifies to negative 1 over 2. So again, I'm looking for two good points. When you're looking at your book examples, it'll be much easier to see good points with the way these PowerPoint setup doesn't always work perfectly, but I got them pretty close. So just again, keep in mind when I'm moving in a downward direction, that's a negative direction on the y-axis, so that's negative 1. So just keep that in mind. Let's take a look at the next example. Example 4, find slope using points. So we're going to start with this idea right here, that slope is rise over run, and that is y2 minus y1 over x2 minus x1. So the change in y over the change in x. All right. So here's an example I want to try. We have the first point 3, negative 2 for E, and the F point is negative 2, negative 1. So I am going to simply set up my y2 minus y1. I'm going to call this x2 and this y2. I'm going to call this x1 and y1. It doesn't matter which one is the first point or second point. Just again, from the lesson yesterday, be consistent. So I'm going to do y2, which is negative 1, minus, that's from the formula, and then the point, negative 2. So remember this from the warm-up yesterday, over x2. So again, being consistent, I started with this y point, so I got to start with this x point. Negative 2 minus, and then my x1 value is 3. All right, so negative 1 minus a negative 2 is really adding 2. And negative 1 plus 2 is 1. And then negative 2 minus 3 is negative 5. All right, and that is just simply written as negative 1/5. So that is the slope of that line for example 4. All right, now we get these out of here. And we're going to try the two other examples quickly. So, all right, back to the pen. All right, so here are some examples. So I'm going to do these a little quicker. I'm going to take the first one. So I'm going to call this the D my point 2 and the C my point 1. And 7 minus 5, so again I'm going from this, I'm going in this direction. 7 minus 5 is 2. And 4 minus 2 is also 2. And 2 divided by 2 is 1. So the first point, the slope of the first 2 points is 1. Now I'm going to use just a different order this time. So I'm going to take P to Q. So I'm going to do 4 minus negative 2. I just want to show that this works. And 4 minus negative 2 over negative 1 minus 3. Again, I'm being consistent, so that's all that matters. 4 minus negative 2 is actually 6. I'm adding those two numbers together. And negative 1 minus 3 is negative 4. Okay? And 6 divided by negative 4 is negative 3 over 2. All right, again, I was consistent, so that's all that mattered. I went from the 1 minus the 3, the negative 1 minus the 3. All right, for C, this is just one with letters. This is actually easier because you don't have to do any adding or subtracting. You just have to set it up properly. I actually want to do this one incorrect. So again, this one's going to be wrong when I do it the way I'm going to do it, because I want to show you what happens when you're not consistent. Okay, what that looks like. All right, so let's say I'm not thinking, and I'm like, all right, I'm going to do D minus B. All right, and so I write that down, D minus B over, and then I'm just going to go A minus C, so I'm going in the opposite direction, and that would be incorrect because I did not, I was not consistent with how I subtract the numbers. So to make this correct, I would have to do C minus A. So that bottom part was wrong, C minus A. All right, and that is example 4. So these are not too bad. You're basically just using the slope formula. All right, let's take a look at example 5. Horizontal and vertical lines. So what I want to do is calculate the slope of these problems. Okay, and so I have this horizontal line, and I often tell kids, if you could think of a treadmill, and this was the belt on my treadmill, what would the slope on my treadmill read? And it would read 0. All right, but we are going to do the slope to this just for fun. So I'm going to pick this point here, which happens to be 0, negative 2. And I'm going to pick, I'll use a different color this time. I'm going to pick, let's just pick this one, why not? And that is going to be 2, negative 2. So that's my first point. And here's my second point. Again, it's 2, negative 2. All right. Sorry about the sloppiness of this. I'm still working on how to write with this mouse. Now I'm going to do my same type of problem. I'm going to do y2 minus y1. So negative 2 minus negative 2 is actually negative 2 plus 2, which is 0. That's where I get my 0 from. And then it really doesn't matter what your denominator is as long as it's not 0. And 2 minus 0 is 2. And 0 over 2 is 0. Okay, so this is a horizontal line, and its slope is 0. Okay, I cannot stress that enough. This is always, it's just basically a vocabulary question when you see these kinds of problems. All right, and you have to know that a horizontal line has a 0 slope. Think treadmill. All right, I'm going to have to get this out of the way. And we'll go back to the pen, and let's take a look at another one. So this is a vertical line. I'm going to do a very similar thing. I'm going to pick this point here, which is negative 2, 0. And I'll change colors again, and I will do, let's do this point, keep it easy. Negative 2, 1, 2, 3, negative 3. So negative 2 and 3 is my second point. All right, put some parentheses around these guys. All right, now this time, again, we're still going to do y2 minus y1. So 3 minus 0 is 3. And again, be consistent. -2 minus -2 is actually 0. Here's where the issue comes in. You are not allowed to divide by 0. I can't have 3 parts of nothing. Okay, so what this is since there's no real answer for dividing by 0, you can't do it. It's not a rule you can use in math. A vertical line has no slope. Alright, so horizontal, 0 slope, vertical lines, no slope, because in a no slope you divide by 0. One of the ways I said might be easy to remember is that on a treadmill, this would be your 0 setting if you've ever been on a treadmill. Alright, and so yes, I can run on this treadmill. I really can't run on that. If you have another clever way to remember that, I'd like to hear it on Friday, so let me know. I have a few other ways. And I hope this video helps, and I will see you guys next time.